So I'm going to give a very brief talk about IPM. I'm going to give you some examples from Australia. I'm imagining most of you know what IPM is. So if you find it a bit simplistic at the start, hopefully it'll get better as we go on. And if there's anything you want to ask as we go along, don't wait till the end. Please just say so. I think Daniel's introduced me pretty well. I'm an entomologist. I'm based in Melbourne, just out of Melbourne, and IPM Technologies is a very tiny company. There's really only two of us that go out, but we work all over Australia and New Zealand quite regularly. So the idea behind setting up the company all that time ago was to help farmers to control pests with minimal use of insecticides, and that's still what we do today. So I'm going to give you some examples of how we've developed strategies, and you might want to look at that and just see what fits for your situation, and we can talk about that. And I should say, and we don't sell anything. So we're not here to push any particular product. We don't sell chemicals, we don't sell insects, so we just help with advice. Usually when I meet people who don't know what IPM is, if I ask how they control pests, they just nominate which pesticides they use. So it's really simple, and that's been the way most people controlled pests probably since the end of the Second World War. That's when synthetic pesticides first became available, and so it has become really easy. You got this pest, you spray that, and that's simple. So I'll try and explain why people come to us to try something different. So instead of pesticides, to me there's actually three control options, and this is the case in any crop. It doesn't matter whether it's vegetables or tree crops or pastures. You've got three things but nothing else, and the important bit is there's nothing else. So the pesticides are there for sure, but there's also cultural controls, which are just management tools. That's just how you manage the crop, and a lot of things that you're probably doing anyway when you grow the crop will influence either pests or beneficials. So you can make things better for the beneficials, or you can make things worse for the pests. Biological controls are the third. So they're just the insects and mites that eat the pest insects and mites. So there, I'm going to show a few pictures of some of them that are probably relevant here, but I'm sure you understand there's a lot more. So all IPM is, Integrated Pest Management, is trying to use all three of those control options in some sort of compatible way. So instead of using pesticides that kill the beneficials, try and use pesticides that are selective if you have to. The I in integrated pest management is the forgotten bit. People often, I'll come back to this, but they try bits of IPM, and so it's putting it all together and using all of the options that makes it work. So this is how typically we would go about designing and then implementing an IPM strategy. We'd fill out this table. Some of you might have done it with me, I can't quite remember, but we just ask you, all right, what pests do you have to deal with? And they're the three options you've got. And so just fill them out. Not all of them are compatible. So when we fill the table out, we'll work out which ones are compatible, which ones aren't, and then we've got a strategy. And so I'll do this, I'll fill this out today as a simple one for potatoes, but you can do it for anything. So let's say this is a set of pests that a lot of farms would have to deal with. Some sort of caterpillar pests, aphids, often the aphids are carrying virus. Thrips may or may not carry virus, so if it's in onions it's direct feeding damage, but in Australia, in potato crops, we worry about them vectoring tomato spotted wilt virus, so it's a bit different. You've got psyllids. psyllids are in Australia as well. They've been in West Australia for quite a few years, but they've just been found in Victoria, and so my guess is they've actually been in Victoria for a while too. It's just they haven't been discovered. So here's some caterpillars and aphids. Quite a lot when we go into a crop, the farmer will say, "Oh, these weren't here last week." But, well, they probably were. You know, there's a life cycle that the insects go through, and so potato moth on the left. There's 5 caterpillars there. If you can see the little one just on the top right, no, that's probably a couple of days old. So it's really small, it's really hard to see. And of course they mine into the leaf, so it makes them even harder to see. But probably takes about 3 or 4 weeks to go from an egg to an adult. So, you know, they've been there for a little while usually. It's about a month. Aphids that are pests, most of them give birth to live young. So they don't go through an external egg stage, it's all inside. So when a winged aphid lands, it can produce the next generation often within minutes, you know. But then that one develops and the same thing happens. With aphids, winged aphids arrive. When they find somewhere they want to be, the next generation has no wings. So you get wingless aphids. Thanks very much. So this is a wingless aphid. So obviously that hasn't flown into the crop. This is the first generation that's come in. This is the second generation. And believe it or not, aphids are quite weird. Those aphids that's just popped out, that's already got the embryo of the next one in it already, because they don't need to mate. So they don't need males, they're all females. They all produce young. So there's 1, 2, 3 generations in that photo. So they can breed pretty quickly, but it still takes time. So you've got some pests, and you know, all I'm getting at is look at all the life stages, not just the big ones. So what eats them? There's 2 sorts of biological controls, apart from the pathogens. I'm not going to talk about like diseases. So there's predators and parasitoids. A parasitoid is just an insect that parasitizes another insect. And so they're quite different, and I'll deal with them one at a time. So the predators first. The predators, it's easy. You can see them. They walk up to their prey, they capture it, they eat it, and you see the results immediately. So lions, ladybirds, they're both predators. You can see where this one's been. So you can see the ladybird, you can see what it's done, and it's all easy. Some of the other ones, which are really, really common all through Australia and New Zealand, would be hoverflies over on the left. Look like little bees. They stand still in the air, usually over flowers. The adults are nectar feeders, they're not predators. So that's why they're over flowers. It's the juveniles that do the eating. Then brown lacewings, incredibly abundant. In a potato crop, if I was looking in springtime in Victoria, I'd probably expect to find 20 to 30 brown lacewing eggs on a leaf, on a potato leaf. That's, you know, I'm not exaggerating. Every single plant would have those eggs on as they move in. So you know how many potato plants you plant per hectare, multiply that by 20 or 30, and that's how many of these there are. They have a massive impact on pests. It's not that occasionally you find them, they're really, really abundant. These things are damsel bugs. So they're a true bug, like an aphid is. They have a sucking mouth part. So this bit here, that's its mouth. So they eat caterpillars, they don't eat plants. So they stab their prey with the proboscis, they inject an enzyme and dissolve it, and then drink it. So yeah, enjoy your coffee. So they're really, really common, and you know, they're important here. but it's the juvenile stages that actually do most of the eating. So picture on the left shows a hoverfly maggot. So looks nothing like the adult. So I'm hoping you can see it, the green thing with the white stripe. It's got no legs, it's got no obvious head, but it can walk around the leaves and canopy of the plant without falling off. And it's got a mouth part like a spear. And so when it finds an aphid, it just stabs it, and once again it just sucks out the contents. In its lifetime, to go from an egg through to the pupal stage, probably eat 100 or 200 aphids. So one of those maggots could easily control, what you'd see as a cluster of aphids. The one in the middle is the brown lacewing larva. And sometimes call them insect crocodiles because they look a bit like that, and they've got a huge pair of hollow jaws at the front. So there's actually 4 jaws, and you can see that one's got the remains of an aphid in its mouth. So once again, they just stab it and then suck it dry. The damselbug juveniles just look like smaller versions of the adults, so they don't go through a pupal stage. So they're some of the most common predators, and all these are they're native species to Australia and New Zealand. The pests that we commonly deal with are not native, potato tuber moth, green peach aphid, diamondback moth. They're all introduced. These don't care. They'll eat anything that's the right size that's in front of its mouth. So they're not things that we brought in from overseas. They're already here and they're part of the landscape. So they're some predators. The parasitoids are much, much harder to see. And that's because they're usually wasps. There's some flies, but mostly wasps. And the female wasp stings whatever it wants to live in. So usually caterpillars. In this case, this example is a diamondback moth parasite. So the picture on the left is the female, a little prong sticking out the tip of its abdomen. That's its ovipositor. That's what it uses to inject the egg into the very, very small caterpillar. So it does that, then the maggot develops inside the caterpillar until it's just about ready to pupate and turn into a moth or a butterfly. And then it kills it and turns it into its own cocoon. So this is a parasitized diamondback moth. So it's not going to turn into a moth, it's going to turn into a wasp. The way you can tell, if you can see it, once again, it's got a white stripe across the middle. Can you see that? Yeah. So they're small, but you can see them. They're about the size of a mosquito. So you can see the adult, you can see the pupa, but in between, they're invisible. The caterpillars would look like healthy caterpillars. So the picture on the left shows a caterpillar. Is it parasitized? Who knows? Yeah, it could be. It looks just like an unparasitized one, so you can't tell. So if you want to find out, I pull them apart. So that's one end of the poor caterpillar and that's the other end. I've ripped it apart. And the thing in the middle is the wasp larva that was inside the caterpillar. So if you get a decent sized caterpillar and do that, you'll find a maggot inside if it's parasitized. So if you're wanting to know, if you're checking your crop and you're finding caterpillars, do you need to spray or not? If you pull 10 of them apart and you find 8 or 9 of them have got a maggot inside, you've got 80 or 90% parasitism. You probably don't have to do anything. If you find none or 1, well, you've got a really low level of parasitism and it's probably worth a spray. So this is a really easy method. It's low tech, it's not high tech. It's something you can do. All you need is reasonable eyesight, or I use a hand lens. So you can assess it in the paddock. You don't have to take anything back and rear them through, which is what I used to do. I used to collect the caterpillars, put them on something to eat until they pupated, and then they turned into a wasp or a moth. And then I can tell the farmer what they should have done 3 weeks ago. So this is a much more accurate thing. So pulling caterpillars apart, I show people how to do it. There's usually a mixture of sort of revulsion and fascination at the same time. They don't want to look, but they can't help. So.
Do they still feed while they've got the...
Absolutely, yep, they still feed, they still do damage. So in the life of a crop, whether it's like a potato crop or a broccoli crop, say, the 2 caterpillar pests that we're concerned about would probably go through 3 generations in the life of a crop. So the caterpillars that are parasitized are still going to eat and cause damage, but the next generation won't be there. So you're controlling the population. So if it's the 3rd generation, just before harvest, whether they're parasitized or not, you don't want parasitized caterpillars up under the heads, you know, that's just as bad. So it's really making sure they get going early. But yeah, I did do many years ago, before I started IPM Technologies, I did a study on rearing one of the potato moth parasites through. I weighed them all the way through, and they actually ate more before they pupated than the unparasitized ones, so they definitely still feed. So there's predators and parasites. Whatever pest you have, there's probably both of those. So the cultural controls are things that you're going to do in your crop, and some of them you'll do anyway, which will influence either one of those. So in potatoes, there's several that are really important, and soil management and irrigation are the 2 keys. So the life cycle of the potato moth, as I'm sure you all know, the caterpillars live in the leaves, and then when the crop dies down or you desiccate it, there's nothing up the top for them to feed on. And so a lot of people believe that the caterpillars, the large caterpillars in the leaves, move out and go down and chew the potatoes. That's almost negligible. That hardly ever happens. What happens is the potato moth, the actual moth, lays eggs on the soil surface, and if the ground is cracked, those tiny little caterpillars, remember the ones I showed you of the 5 caterpillars, those things that are about 1 millimetre to 2 millimetres long, will drop down hairline cracks in the ground and get onto the tubers, so that, you know, each moth might lay 50 eggs or so around a plant. So if they've got access, they will get into the tubers. So to stop them doesn't need very much. They're not big, they're absolutely tiny. So even a film of very fine soil particles will cover them. Probably need between 0.5 centimetre to 1 centimetre of soil cover, that's all. But if the ground's cracked open, so if you've got a big centerline crack, what do you do about that? So irrigation can actually wash, it won't fill it in, you know, to the top, but you can wash soil particles in to produce a fine film over the top. Or you can use, some people use rollers, crumble the soil. You don't want to punch stones into the tubers, but you know, the soil cover is the thing. If you're a seed grower, there used to be a requirement in Australia and New Zealand to be away from other commercial crops. That's not there anymore, but still seed growers that want to grow clean seed will often choose a location that's isolated. That just reduces the risk of aphids that might vector viruses coming into their crop. There's a whole lot more. I can talk about them later, but there's a range of things you can do. Even the variety, excuse me, variety or time of planting, that's huge. You choose a low setting variety versus a high setting variety. That means, you know, the amount of soil cover you need, it's going to be easier or harder. Some methods I can talk about more if you want. We get growers to use sacrificial plantings in some cases, and there's a difference between sacrificial plantings and trap crops. So a trap crop, you plant something, you draw the pest in, and then you can spray whatever you like on it and get rid of it without putting that spray on your crop. Sacrificial planting means you draw the pest in just the same, but you want beneficial species to follow it. So then you can bulk up a whole lot of beneficials, but the plants are damaged. So there's no intention to harvest those bits. You can provide a nectar source for beneficial species. Those tiny little wasps that are, this size, if they just get water when they emerge as an adult, they'll probably only live for 2 days. They're not long-lived, and in those 2 days, they've got a mate and then lay eggs, sting some caterpillars, which they'll do. But if they get a nectar source, they might live between 60 and 90 days. Like, there's a big difference between 2 days and 60 days. So that nectar source is usually just flowers. If you're growing onions, leeks, if you want to create a habitat on the soil surface for predatory mites that control thrips, you can bulk up the population 1,000-fold. So you want predatory mites on the soil surface. I'll show you this in a minute. In Australia, with diamondback moth, we've got a problem at the moment. The moth has developed resistance to almost every insecticide that we've got. So if you know, some of the names are different, but I think you've got Steward, Proclaim, Success, or Sparta, Corrigan. Well, they don't work anymore. So imagine you've just lost all those. What are you going to do? Like, things are not good. So so what we did, the little wasp I showed the picture of, we bulked them up in our lab. We let some go in a crop, and they had a really big impact on the pests in that crop. So we're not a commercial insectary, so we gave that colony to a commercial insectary in South Australia. And so if you were in Australia now growing brassicas, you can buy Diadegma wasps to release into your crop. You've got Diadegma here too, and you've got a biocontrol producer just out of, well, actually he's pretty close by. He's somewhere. Got 2? Yeah, so if there's a demand, they would probably do that. I don't think there is a demand yet because you've still got chemicals that work, but when the time comes, that's another option. I'm not talking about buying so many that they give you instant control, but when you come and plant the first planting, you can put the wasps in and so overcome the lag between the arrival of the pest and the naturally occurring movement in. That might take some time. So this is in Werribee South, just out of Melbourne. It's where I go once a week, and they've chopped down pretty much every tree and bush in the area. There's nothing but broccoli, cauliflowers and lettuce. That's it. But there's weeds on the dam banks and the old irrigation channels. We ask them actually leave those. The aniseed weed is a really good nectar source for beneficials. There's marshmallow weed mixed in. We ask them to get rid of that because it's a food source for some pests. But the aniseed weed actually is quite okay. And it's the only nectar source around, so just leave it, which I'm quite happy to do. So you can even, so if there's somewhere along fence lines or road edges, whatever, you don't have to have a nectar source all through the crop. Those wasps will fly 100 or 200 metres from a nectar source to wherever they want to be. So just an edge of a paddock is fine. This is an example of a sacrificial planting. This is an organic brassica grower. So he can use BT sprays, so things like Dipel or Zentari, to control diamondback moth and cabbage whites. He does that very successfully, but he's got nothing that's IPM compatible for controlling aphids. So usually he plants his crop, aphids come in and they make a real mess. Then the beneficials sort of come in He plants his second planting. He's got a few beneficials there, but there's still a lot of damage. Then he plants his third planting in the paddock. That's okay. It doesn't hardly suffers at all because all the beneficials are all there. So what we got him to do was plant a strip of kale. He doesn't want kale. I don't think anyone wants kale, but it's on the outer edge. It gets hammered with aphids. It looks terrible, but then the lacewings, the ladybirds, the hoverflies arrive. So he does this about 4 or 5 weeks before planting his first lot of real brassicas, and there's no lag. All the beneficials are here. So his first real planting doesn't have an aphid problem. So it just means he's got to plan ahead. He's got to be able to get that planting in and keep it alive for a few weeks before he plants his others. Does that make sense? So this is in onions. If you look at where the onions are, and I'm sure you all know what onions look like, there's onions and there's bare dirt. There's nothing else. There's absolutely no habitat for a soil-dwelling predator. So what we have people do is put mulch down, and the mulch can be whatever is around. In this case, it's chaff. We've used chook manure, different sorts of manure, we've used silage, whatever's around. What it does is it traps moisture and it rots down. That attracts fungus gnats. Fungus gnats are the tiny little flies, the little annoying flies. Sometimes you get them in pot plants in your house, but they are the food source for predatory mites. And so the predatory mites are there naturally, you don't have to add them. But in that sort of environment with the onions, there's not many of them because there's nowhere for them to live, there's nothing for them to eat. So it bulks them up. And the next slide I'll show you is where a grower has done this. He's put a layer of organic matter in between, it's actually in between 2 rows of leeks. And the compost has been there for about 6 weeks, and I'm going to pick up a clump of it and show you what's underneath. So this is the organic matter in the middle of the row. That's a lump of it about that round. And all those things moving are predatory mites. All of those eat thrips because they've eaten all the flies. There's nothing else left except the thrips in the leeks or the onions. So we've had growers do this in many states. So that's where the background level was really low, but simply by changing the habitat on the soil surface, we've got a huge population of predators that we want.
With predatory mites being on the soil and thrips being up in the plant, are they going more for the pupae stage that drops down into the soil, or are they climbing underneath?
No, so they, as you could see in that little video, like as soon as I turned it over, they wanted to get out of the light. They ran away. So they probably would eat the pupae in the soil surface, but actually they go into the developing onion or leek when it's in its young stage. They come out at night, they're nocturnal. And so they'll go into the growing tip where the thrips are. So that's a good point, yeah.
How often would we have to put a mulch then?
Once, just once.
I mean, how far apart?
Oh, sorry, how far apart? Yeah, I mean, if it was me, I'd say every row, but in onion crops, what people have done, they don't want to disrupt sort of everything else they're doing. So it's usually the tractor wheel marks. They put them down those. You can drive the tractor over, you won't squash them. So, they'll survive in that habitat. But that's where people have done that sort of multiple times because it's out of the way. It doesn't interfere with other things they're doing. So what's that, about 2 metres apart? Something like that.
Onions, New Zealand, we did a bit of work on this a few years ago. We, probably pinched your concept as much as,
Probably.
learn from it. Where we ran it down, we didn't go down the wheel tracks because we thought the repeat traffic of the tractor would squash it, we'd lose that moisture, it would dry out and all of our life would exit, right? So we put it in between the beds. We used silage. Yeah. And I think I mean, we definitely had thrips, but at the same time, we were able to reduce insecticides
Yeah.
a fair bit and still have effectively the same
Yeah.
same result in the treated and untreated.
It does work. And yeah, where you put it, it's up to you. In the case of the leek, we've had celery growers do it. They do it in every row because they've got a bed, you know, it's raised and they put it down the middle. But yeah, wherever it goes, they'll move a few metres either side. So yeah, the results are there.
How's it applied? Is it labour or mechanical?
So when we did the trials, like, you know, talking to you now, you don't believe it. So, you know, you're not going to invest in machinery to do it. So the first year, people put it out by hand. Second year, they work out, well, how can we do this? So in Australia, people have developed their own equipment. Sometimes, I've only ever seen one person that's already had existing equipment. It's where they, you know, were chopping up cauliflowers or something and spitting the residue out off to the side. So it's something like that. The growers that we did it with in South Australia, they got multiple centre pivots and they won't tell me what they did. So they said, oh, we did the work, we're going to keep it secret. So, but basically it's something that is a side dresser that you can, you know, lay out a row of stuff, you know, that how you do that.
Yeah, when we were looking at next steps for the onions project, we were looking at a slightly modified compost spreader. So you could effectively fill the compost spreader with silage and then just, instead of just dumping it behind it, have a small chute that just dropped it behind the wheel and filled the bed. And what did we do where we used wood chip one time, we just used a bale feeder and then again just kind of off-centered it a wee bit so that it dropped more in the wheel track rather than outside of that. Yeah, that's where.
So basically there's no existing equipment, but it's not too hard to imagine making something and modifying it. But it's only worth doing that if you believe it's going to work. So in South Australia, they invested in some equipment that they were quite pleased with. Harvest Moon just modified some, in Tasmania, just modified some existing equipment. So yeah, obviously it's got to go from doing it by hand on a, you know, 30 by 30 square metres to something you can do whole paddocks with, and people have done that. So.
Have you ever used weeds like grass weeds, for example, in rows and sprayed them off on a long-term crop like onions, where you get beneficial effects of wind shelter and,
Yeah.
And then spray it off and just about mulching it?
Yeah, we've looked at that and it doesn't work. It would be great if it did, but unfortunately what we want is stuff lying on the ground that retains moisture. And even where people have used, you know, like chook manure and stuff, if they've spread it out too thin, it's not a fertiliser that you're putting out, it's, you know, something that's got to be a lump of stuff. You could see from the little video, like it was like a mound of stuff and it was moist underneath. That's what you want to do. So if it's sort of the remains of grass that's standing up, that doesn't do it. Wish it did, but yeah. So the third one is pesticides. So the difference in an IPM strategy is that the pesticides aren't the first and foremost thing that you reach for. The other two that I've just described are the first. The pesticides are there for when they're not enough, and quite often they're not enough, but you want to know, all right, I'm going to spray something, but I've just built up all these beneficials. The last thing you want to do is kill them. So what can you use? So pesticides, the old pesticides, the organophosphates, synthetic pyrethroids, pretty much you could say they're going to kill everything, you know. But the newer ones, they'll kill some things and not others. Some are really safe and won't kill just about anything. So there's a range of choices. We need to know. You can't predict what they're going to do. Some will kill ladybirds but won't kill lacewings. Some will kill wasps but won't kill hoverflies, you know. So we test it. And other people test it as well. So I'm going to show you some side effects guides. Don't worry at all about what's written there. It's just a chart that is very common where people colour code the toxicity of the pesticide as green, yellow or red. It's like the traffic lights. So what we've got on the left is a list of insecticides. The columns each refer to a different species of beneficial, and the colour is green, yellow or red. So you can find multiple sources of this online. They're all free. You can look them up. You can look up our website. We've got our own as well. But this is the typical one. I'll show you ours in a minute because ours is better. But you know, this one here is from GRDC, the Grains Corporation in Australia, and you can find the same stuff in great detail on the cotton website. Coppert and BioBest are biocontrol producers. They're international, and they produce bumblebees and a whole range of predators and parasites. Most of it's for protected cropping, so in glass houses, but there's a whole lot of overlap. So you can look up the impact of a pesticide on a lacewing or a ladybird. They're different to ours, but it'll give you a guide to what's there. It's all free. You can. This one has a pretty good app actually. You can get it on your phone. So green, yellow, red. Okay, so the green ones are safe, the red ones are not safe. But if you look, I'm going to zoom in on the legend at the bottom. So what does it mean? So we do these tests in pretty much exactly the same way. We put insects in a container, we put the pesticide on somehow, usually a dried residue, not a liquid, and we measure what the mortality is after 24 or 48 hours. So green means up to 30% are killed. Moderate means up to 80% are killed. So that's a pretty broad brush, I reckon. So you wouldn't go and happily take some medicine if the doctor told you probably it only kills 30% of people, you know, and this has killed them, you know. So it's not an absolute measure of safety. It's a way of ranking the relative toxicity. So red, and I think they've gone overboard here and they've subdivided 99% kill to 100% kill. I don't know why on earth they did that. So this is what we've done, exactly the same tests, and green to red. So there's a range of insecticides on the left, but instead of doing them in little boxes, we've gone on a continuum. So, and all the letters that are there, so the top AC, OP, they refer to the different species of beneficial that we've tested. And so I think you can see at a glance, well, that first one, that's a miticide. It's pretty safe to those beneficials that we've tested. And you can see exactly where it is. So it's way below 30% mortality. But if you have a look at this one, Avatar, it's sold here as Steward. Is it safe or not? You know, it's got some down the green end, few in the middle, and some right up in the red end. So whether Avatar or Steward is safe or not depends what you want to look after. If you want to look after ladybirds or aureus predatory bugs, well, it's not. But if you wanted to use it on Incarcia, Persimmilus, Cucumerus, those certain beneficial species, it's safe. So what the point of this is to show you that there is no safe or not safe. It's what you want to look after. So your monitoring tells you there's lacewings there, so you want to look after the lacewings. The other thing you should notice, oh no, I'll keep going. So if you want those, on our website, we did the testing for a project funded by Vegetables Australia, and it finished a couple of years ago. But we produced 7 guides. In Australia, there's 7 different categories of vegetables, and each has different set of pests, different set of beneficials, and different set of products. And so we've just grouped them into 7 lots. It still is on the AusVeg Australian website, but it's so hard to find that I stuck it on our website. So it's really easy to find. There's a button up the top on the home page, and you can find it. But there's a couple of things apart from those categories. It's all it is, I'll emphasise, is a way of ranking one product versus another. It's not safe or not safe. And all the tests, ours and the ones that I've mentioned from other places, it's one spray at the label rate. So if you use 2 or 3 sprays, goes from green to yellow or yellow to red. And if you up the rate, if you use 1.5 times the rate, it's probably going to do the same thing. So it's acute testing, it's mortality. So if you kill 30%, well, all right, we've got 70% left. Are those 70% really fighting fit, healthy, going to produce as many eggs as, there's sublethal effects as well. And to do those tests, it's so expensive because it takes so long. If you want to find out how many eggs does a ladybird produce, you probably have to do a study for a year because they live for a year. So, so basically it doesn't get done. You only will see the results yourself in the field. There's one other complication. If you're all growing outdoor crops, it's quite straightforward, but if you're growing under glass or plastic, it screens out ultraviolet. There's no overhead irrigation, there's no rainfall. And so if you sprayed something like lanate out here, then it would be gone in a day. You spray that under there and it will kill any beneficial you put in for 3 months. Like, it's not a little bit different, it's massive. When I first started doing this, I didn't believe it, but it's true. So if you look up maybe the Coppet website, they have a number after each of the pesticides with the testing. And if it's red, it might say 4. That means 4 weeks, it'll kill everything. It might have 12, that's 12 weeks. And so most of the synthetic pyrethroids and organophosphates sprayed under glass or plastic would have a residual of 12 weeks on beneficials, not on the controlling the pest, but on. So if you're buying stuff and putting them in, you really need to know that. How we going from time? I'll just quickly go through some examples of where people have changed. I'm going to rush through this because it's getting a bit late, but we've done it in celery. So the celery growers we worked with, they used to spray probably more than a dozen times in 12 weeks, maybe twice that sometimes. And now they would spray once or twice. So they use IPM, they use selective insecticides. These are huge growers, they're not small. Same grower, a couple of growers grow leeks, they use no insecticides, absolutely none. Potato growers, well, we've gone through all the things that you might do. I started off working in potatoes probably over 40 years ago, and this grower I met probably 25, 30 years ago, and it took him 3 years to go through, all right, we'll give it a try. Then second, all right, that worked, we'll do a couple of paddocks. Third year, did the whole farm, and he's done it ever since. He used to spray every paddock 7 to 10 times with insecticides, depending on what he thought. And he told me this, that in the last 20 years since he's used IPM, he's used less insecticide in total in 20 years than he would have on one paddock for one season. So this is a mainstream grower. It's not a, he's not doing it for any philosophical reasons. He's a crisping grower, and his product is good. He's a really good grower, and he's just changed the practice. It took him 3 years to believe, but he now follows it. The spinach, everything you see there is spinach. He's using the sacrificial plantings that I mentioned to try and bulk up parasites of leaf mining flies. And doing that he's more than halved his insecticide bill. And yeah, and there's no compromise with any of these on quality. They're not sacrificing a little bit of, it's not so bad. They're good. Most people come to us to improve the quality. The onions I mentioned, no one believes me here, but they used to spray 7 to 10 times, every 7 to 10 days. And these are big growers. If they use one insecticide now, that would be it. Most use none. So I know you don't believe me, but strawberry growers, they had a crisis in the Yarra Valley about 10 years ago. No, maybe a bit less. But they were spraying lanate every 3 days. So it's got a 1-day withholding period. So they would pick, spray, 1 day grace, then they would pick, spray. And that was what's got written down, like there probably was a bit more than that going on. So they had to change. They had no choice. They were losing the crop with that. That wasn't successful. So they were abandoning strawberry crops in March rather than May. So there was a massive yield loss. Now they don't use any broad spectrum insecticides. Most used hardly any insecticides. This is a cabbage grown just outside Melbourne that's had 4 insecticides a week from transplant to this point, and that's the result. That's what happens when they get resistant. So he's using IPM now. He sprays really soft insecticides maybe every 2 weeks. This is a Brussels sprout grower. I met him a few years ago and we went through what was needed, and he didn't like using some of the soft insecticides like BTs because he would have to spray them in the afternoon to avoid UV degradation, and he didn't want to do that, so he didn't do it. And then he rang me about 2 years ago and said, can I come and help him? I said, well, I can, but you don't do what I say. And he said, I'll do whatever you say. He lost 1/3 of his crop, ploughed in, 100% loss, and that's an expensive crop. Now he does the same thing. He gets his crop. So they're not doing it to save money on pesticides, not at all. They're doing it to get their crop.
That's quite important, Paul, spraying late evening, late afternoon, as opposed to...
Just for the BT sprays. So the problem here is all the conventional pesticides that I mentioned before, that's what he was using, and they were resistant to that. So the ones that still work for us are the BT sprays. So Dipel, Centauri, but they get degraded by ultraviolet. So if you spray it in the morning, it's all gone by lunchtime. You spray it at 3 o'clock, it works all afternoon, all night, all next morning, and it's gone by lunchtime. So it really is important. If anyone does want, we've produced a 1-page note because everyone asks the same thing. We've got a 1-page note on how to use a BT and make it work. If you'll pass it on to anyone that wants it. Yep. So I'm just going to fill out this just to show you how it works. We've got our pests of potatoes, tuber moth, aphids, thrips, psyllids. There are soil pests, but I'm not going to touch that today. We've got all these things that eat them. So there's a range of stuff. It's all naturally occurring. You've already got them. You don't have to do anything. They're already here. The cultural controls, there's many more things, but soil management and irrigation. The seed source, if you've got virus and you're worried about virus, obviously certified seed is much better than kept seed. Isolation, if you're a seed grower, you might want to do some border plantings for nectar sources, but there's a whole lot of stuff you can do that will influence either the beneficials or the pests. Then there's pesticides. So I've put in here, from an Australian point of view, this is what we could use. The ones in brackets we could use, but almost never use because we don't need to. We're not relying, this isn't the new spray program. This is only if needed. So seed growers would probably put on an aphicide, whether it's needed or not. You know, they just want to be sure there's no aphids. And there's a whole lot of soft aphicides. And I've only got one thing written for psyllids. The psyllid's been in West Australia for quite a few years. It has never caused a problem in potatoes. No one has ever sprayed for it in potatoes. They do in other crops in West Australia, but not in potatoes. I believe
You guys don't have Liberibacter in your solid.
Liberibacter,
Unless you haven't detected it.
Liberibacter hasn't been detected.
Yeah.
If you don't look, you don't find it. So,
Okay.
and yeah, and you can look, but it's how hard you look too. So it could be there, it might not be there. So, but yes, it hasn't been detected, and so there's not a huge risk. But because if you look at the biocontrol agents that I think are important, and we actually did this work many years ago. We contracted Plant and Food here in New Zealand because we didn't have the psyllid at that point to do the trials. Most of them were done here in Auckland. Would those predators eat psyllids? And the answer was that every life stage of those predators ate every life stage of the psyllid. So if you've got an IPM strategy, you've already got all the things you need to control psyllid. And Australia has a lot of predators of psyllids on top of that. So we have never needed it. Here, there would be a range of things you could use that are soft that you could spray for psyllids. I've given an Australian example.
Okay, so that's the pesticides that you're saying would be compatible with an integrated pest
Yes.
management program. So
Yeah.
obviously we could probably make a broad sweeping statement that, and you've already said it right, that SPs and OPs will wipe the floor with that beneficial
Yep.
portfolio. But if we look at some of the other products that are available for, say, tuber moth control,
Yep.
where does something like ivermectin?
So if you looked at that chart that I showed before, or if you want to look it up, you can find it exactly. But ivermectin is quite disruptive to most beneficials. So it's not as bad as the SPs, that's for sure. But like I said, you want these things to be doing well, not just ticking over. So ivermectin is not good. Things like indoxacarb will kill everything, but is not residual. So you could spray it early in the life of the crop before beneficials arrive. But if you sprayed it in the middle of the crop, it would probably cause quite a bit of disruption. Spineteram will kill wasps for sure. And if, you know, the wasps are pretty important in controlling aphids and caterpillars. And spineteram is going to kill some more predators as well. I'd have to check on the charts, but it will, the old spinosad was much softer on the predators than spinetoram is. Any others?
What am I forgetting?
So transform, that's a very difficult one for us to answer. It's like it's in the neonicotinoid group. In our test, which is done in Petri dishes in the lab, it kills everything. But outdoors, it doesn't, you know. So Corteva will tell you it's totally safe. And outdoors, in a lot of situations, it quite probably is. But our tests show that it kills things. So the halfway house is the glass houses, and people who've used it there say they've noticed disruption of predators. So I think if you were to spray it on a potato crop, it's probably not going to be a disaster at all. But I don't list it here because we've got other things we can use that I know are safe. Yeah.
What about the likes of Perimecarb?
So Perimecarb is, you spray a liquid, it turns into a gas and fumigates the aphids. So it's all gone. It will kill some parasitic wasps, but only the adults are there that day. So if you use it once, its impact is pretty negligible. With Pyramora, can also add, if you are going to use it, It's almost the opposite of a BT spray. You want to spray it in the morning when the sun's going to hit it and you're going to get that fumigation action. If you sprayed it late in the day when it's sort of getting cooler, it doesn't, it sort of dribbles out rather than boomf. So,
What are your thoughts on crop oils in IT?
so they're not residual at all. It relies totally on contact. So if you can contact the target pest, it kills by suffocation. It'll do that to the beneficials as well. But because it's not residual, it's a bit like what I said about Avatar. You know, you could spray it and all the beneficials around would come back in the next day.
As long as you've got beneficials.
As long as they're
outside
around.
the treated area.
Yep, yep.
But you're going to be killing your hoverfly larvae and those sorts of things with it at the same time.
Well, it relies on contact. So, you know, if you've got a dense canopy of potatoes, I don't reckon you're going to get too many of them.
You're probably not getting too many pests.
That's right. It relies on exactly the same process. So yeah, if it's small plants and you can get good coverage, you'll get an impact. But the bigger the plant canopy gets, the less efficacy you're going to get on the pest and the less impact on beneficials. So
I do have another question. It's a sort of two-parter. Have you done any work on the impact of other pesticides, i.e. fungicides,
yeah,
and herbicides on some beneficials?
yeah.
And I suspect they probably already know the answer is no, but on combinations.
No. Oh, well, combinations, no. We haven't done combinations. Each one has been done on its own. In that list, you'll find some fungicides listed, but it's the same all over the world. Most information is on insecticides and miticides because they're designed to kill insects and mites. So you want to know that. The fungicides, there's a lot of information on fungicides, but not quite as much. And herbicides, there's practically nothing, you know. So that's just how it is.
I think the big one would be mancozeb, right? Or what?
Chlorophyllonyl.
Was that all?
Chlorophyllonyl, I understand, it's a real problem.
On beneficials, we wouldn't.
Beneficials.
Yeah, we'll have to look in our book. It's pretty widely used in a whole lot of crops. We haven't seen disruption in veggie crops. Doesn't mean it's not there, but mancozeb is disruptive to predatory mites. It's not too bad on other things, and predatory mites, I would think, are not important in potatoes and brassicas, but are really, really important in things like tomatoes and glasshouse crops. So mancozeb is the worst thing you could use in a glasshouse, but totally safe in potatoes.
But if we were, so onions,
Yeah.
right? If we were to go in and do this mulch technique,
Yeah.
mancozeb's a relatively
If you can,
in a fungicide program in onions, right? So
Yeah.
would we be?
the predatory mites there are in that organic matter. So in a lot of ways they're protected. So they'll come out and they'll walk over the mancozeb, but they're possibly not going to get like the full dose as an insect that's exposed up on the canopy. But it's not a disaster, but if you could get rid of the mancozeb, it would be much better. Yeah, because we've got predatory mites as the key for controlling the pest mites. So yeah, it would be better if you could avoid mancozeb, if there was an alternative. I think I'm at the end. So I'm suggesting in all these cases that I've showed you where there was successful IPM, no one switched over their whole farm on day one. They gave it a try on a paddock, and you probably want to do that. I'd be confident, but everyone's got to see it themselves. So yeah, I'd pick a paddock, do pests, look for pests, look for beneficial species as well. But just remember that with IPM, the I stands for integrated. And so a lot of people say, oh, well, we put nectar strips out, but then they kept spraying stuff. So, you know, they're not doing the whole thing. It's the whole strategy that works, not the elements that, you know, make up the whole. If anyone wants to contact me, you can either do it via Daniel, or you can look up our website. Our website has the pesticide charts. And so I showed you one page of one guide. There's a whole lot more than that. So So thanks for listening, and if there's more questions, or I don't know how much time we've got.
Yeah, well, I mean, if there are any questions, now's the time. Or what we could do is we could close this off, and we have a little bit of time if you want to talk to Paul a little bit more in a less presentation type format. So I guess any last chance for questions, you know, in general now with everyone, or we'll close it off. How?
You're saying about like you can buy like Pigma wasp and that and introduce them, but what is the other food source? Do you have food source on your farm for them as well?
So the adult wasps just eat, you know, pollen and nectar. So flowers is what the adults would go for. The juvenile stage live inside the body of the caterpillar, and that's all the food they need. In fact, they can't live on anything else. So it's yeah, they don't need much at all.
So if you did like a Phacelia or buckwheat cover crop on the edges of the potato crop,
That'd be enough. Yeah, yeah. So like I said, they move far more than you might expect. There was a guy in Adelaide did some radio tracing on it, and you know, tracked individual wasps to see where they went, and it wasn't just a few metres near the flower strips. You know, they went hundreds of metres.
Sorry, question on the audience. You said they're down to one drip spray. Is that because the threshold's been met, or are they doing a clean-up spray before harvest?
Sometimes people get worried, so they put something on and it makes them feel better. How much it's doing, you know. I mean, the people that came to me were spraying things like dimethoate, chlorpyrifos, doing it every 7 days, you know. So, you know, when that was failing, that's the only reason they tried this ridiculous thing, you know. But they did try it because they were desperate. And so one spray is actually, that's only when they get worried. And so they probably use Benivia or maybe Movento. That's it.
I got one last question.
Yeah, yeah.
On the BT, is there any concern about resistance to BT, if that's your sole strategy?
Yeah, I'm worried. Yeah. Resistance to BTs has occurred in places like Thailand, the Philippines, Florida, and that's where it's been overused. And so there's 2 types of BTs, so Bacillus thuringiensis kerstaki and BT isawai. And so they do actually have different toxins, and so if you're using a lot of BTs, it's best to alternate through those. There's a lot of BTKs, you know, all with different trade names, but Centauri is probably, as far as I know, the only one that's the other. You can get mixtures of the two, and I'd suggest probably best to avoid those because you're losing the resistance management option by putting them both in together.
Oh, down the back.
Just the situation quite often happens in spuds. You're trying to look up the beneficials early because you've got to come in hard later on anyway with the psyllid. But quite often get a outbreak of cutworm early on.
Yeah.
What would you suggest a good management strategy for that to try and?
So big caterpillars nipping off the whole plant, or?
Oh, yeah, they get right of the stem.
Yeah. Yeah. So it could be that they're coming as a carryover from whatever was there in the previous, you know, crop or even weeds. And so looking at dealing with them in the crop prior is one option. BT sprays will kill them if you can get them to eat it, they will kill it. Or almost any of those, all those ones that I said failed on diamondback moth, almost all of them would still work on cutworm. If it was really early in the crop, something like chlorpyrifos is what's usually used, and that will kill them. It's not ideal, but it won't. If you do it early, it's not going to interfere with all the things that I've talked about for controlling potato moth, aphids, psyllids, because they'll all come in later. So if you can do a disruptive hard spray as early as possible would be the way to avoid the disruption. So even chlorpyrifos, you know.
Just want to make a statement, Daniel. like, we're running a lighter touch here, and I think we have proven that IPM does work on all the crops that we're growing. Minimal use of insecticide. We've actually taken our thresholds right well above the normal threshold and still controlled, especially aphids. I feel they are quite easy to control. We've done it with broccoli, where we haven't had an insecticide on. We've only had one fungicide on the crop. We actually could have got away with that. So we have shown that we can work, but you need a system of providing food for the beneficials. All those flowers, all those flowering strips, all our native plantings, the pods that we're using, that we're putting out on the crop. So all of that is getting written up, and it just shows you that if you really want to do it, it can be done. It can't be done straight away. You need your plantings to bring in the beneficials and improve your biodiversity first.
And I think that's exactly what we're talking about. It's that eye in it, right? It's that integrated. There's no point just doing the flower strips, or there's no point just trying to reduce your insecticides. You get the best bang for buck by bringing it all together and managing your crop under that. You're stealing my thunder for the closing of this house. Good on you. Last question.
Just with the border plantings, Paul, what's your preference, around the outside of the crop or strips through the crop? Or?
Well, like I said before, because they fly hundreds of metres, probably around the edge of the crop, even like if you can set up something permanent on the fence line that self-sows, it's easier and maintains itself. So there's no need to go for strips through the crop, which probably get to be a bit of a hassle. Okay.
And on that note, could we all just do a bit of thanks for Paul and his talk?